We will study definition of magnetic field. We know that a charge at any location experience a force if there is an electric field which is created by another charge somewhere in the vicinity. Now, if this charge is moving q and it has certain velocity v, it is moving, then according to our laws, it should keep on moving in a straight line. Law of inertia of motion, it will keep moving on the straight line. Now, if a force is applied on it, there can be three effects. Its speed may increase, its speed may decrease, and third effect is its direction is changed. So, if a charge is moving and either of the three is happening to it, then we say a force is present. A force is applied on it. A body is, if a charge is going straight and it moves like this, that means something has pulled it. That is why a force is applied on it. Okay. Now this charge is going straight. Suddenly we find that it has moved like this. We say a force is applied on it. But who has applied this force? What we see here is a charge is flowing somewhere in a current. This is a conductor, an infinitely long conductor, and in this conductor the charges are flowing, or we can say current is flowing. Now one thing I would like to make clear here, you should always remember, what is the net charge of a conductor in which current is flowing? So remember, the net charge of a conductor is 0. In the current, you will say the electrons are moving, it is a charged body. No, it is not a charged body, because here if there is no current flowing, the net charge is 0, because plus and minus are equal. Okay, now what happens? One electron enters and one electron leaves. So again net charge is 0, again one enters, one leaves. So electrons are moving. So at any time, the net charge always remain 0. So remember, a current carrying conductor, how much charge it has? 0. Now if its charge is 0, how much electric field it can create? Answer 0. Because electric field is q upon r square and q is 0. So electric field created by this is 0. This is not capable of creating any electric field. Now I start current in this, and this charged particle which was moving straight bend like this. In this direction, in that direction, we will see the direction rules later. But it changes its direction, and changing direction applying force. Without contact, who applies force? Electric field, any field applies force. Now this is incapable of creating electric field. No. Then what it is creating? We say a force is applied on it, and now this field which is created by this current is called magnetic field, because we have seen that if we place a magnetic needle here, that magnetic needle also moves. So that is a proof that the field created by electric current is magnetic field. Now what we see, when electric current flows here, it changes its direction. And this phenomena gives us definition of magnetic field. A magnetic field is the field which is able to change direction of a moving charge. Again, magnetic field is that field in a space, that is that property in a space which changes the direction of a moving charge. This is definition of magnetic field. Not that was old definition, the field created by a magnet, because inside the magnet there is a current flow. Because of that current, this field is created. So we have to define it again, and this is the new definition we have made, and I will write it for you. Magnetic field, a very simple definition. Magnetic field is a property in space which can turn a moving charge. That's all. So this is definition of magnetic field. Now we will quantify it. How much is the strength in this magnetic field? What is intensity of this magnetic field? So we will do. Now, what is shape of the magnetic field? That is also to be seen. So we will, in the next lecture, we will see what is shape of the magnetic field. What is that shape? How do we decide? We decide the shape by the direction of the force. If direction is in this direction, then we will say this is direction of the force. This is direction of the field. If it is this way, this is direction of the force, then this is direction of the field. So field means force. Whatever is the direction of force at any point, that is direction of the field at that point. That is in physics. So in the next lecture we will make it that what is the shape and what is the quantity of the intensity of the magnetic field. Thank you.